Pick up a piece of coarse gray granite at any creek bed, and there is a real chance you are looking at the exact same rock type that produced an 18-carat emerald worth $5.5 million. That stone, the Rockefeller Emerald, sold at Christie's, New York in 2017. John D. Rockefeller had owned it since the 1930s. It started as green beryl locked in a Colombian pegmatite, and here is what makes that matter to you right now. Pegmatite is not rare. It is the coarse-grained granite that forms when magma cools slowly, and it is in every mountain range on Earth. By the end of this, you will know how to run a specific gravity float test using a $49 O-House scale and an $8 plastic cup, how to use a $35 dichroscope to read optical phenomena invisible to the naked eye, and how to narrow down a mineral family in the field using a Mineralab hardness pick set. 5 families. 5 different ways a common mineral becomes something extraordinary. The Beryl family is where I started, and it is the one that humbles you fastest. Emerald, aquamarine, and heliodor are not 3 separate minerals. They are the same beryllium aluminum silicate with different trace elements locked in the crystal lattice. Chromium turns it green, emerald. Iron gives you blue, aquamarine. Oxidize that iron, and you get yellow heliodor. The crystal does not change. The contamination does. The host rock is everything. Pegmatite, that coarse-grained granite formed as magma cools slowly, is where beryl grows big and visible. In the field, rough green beryl looks like broken bottle glass jammed into gray rock. That greasy hexagonal face is the signal. The Rockefeller Emerald came from a Colombian pegmatite where a beryllium-rich vein hit a black shale loaded with chromium. That intersection, beryllium from one source and chromium from another, is the only reason that stone turned green instead of blue. The specific gravity float test separates beryl from quartz before you crack anything open. O-House YA501 pocket scale, $49, $8 plastic cup with a water suspension rig. Weigh dry, weigh suspended, divide dry weight by the difference. Beryl runs 2.68 to 2.80. Quartz is 2.65. Close, but measurable. Garnet comes back at 3.5 to 4.3. That gap is how you sort a mixed creek pan without breaking a single stone. But the Beryl family is not the one that truly defies logic. For that, you need corundum. Ruby and sapphire are the same mineral, aluminum oxide, hardness 9. The only difference is which trace element contaminated the crystal. Chromium makes ruby, iron and titanium make blue sapphire, and the same stream gravel that holds a blood red ruby also holds blue sapphire. I have panned corundum pebbles from the Missouri River terraces in Montana and pulled both colors from the same bucket of gravel. The parent rock erodes. Floods carry the crystals downstream, and they sort by density, not color. The textbook field example is anyolite, also called ruby in zoisite. First found in Tanzania near Mount Kilimanjaro. The specimen looks like someone painted red blotches on a green rock. The green matrix is zoisite. The red concentrations are corundum, and the black streaks running through it are hornblende, which is worthless. When you break an anyolite specimen, you target the red, not the black. The Mohs hardness test tells you instantly whether the red material is corundum or something softer mimicking it. A Mineralab HD1 pick set runs $89 to $135 and covers the full 2 to 9 scale. Corundum, hardness 9, scratches every pick in the set except the hardest. Nothing softer than a 9 does that. The Sunrise Ruby went to auction at Sotheby's Geneva in May 2015. 25.59 carats. Pigeon's blood color. Untreated. Set by Cartier. Heidi Horton paid $30.3 million. $1.18 million per carat. That is the record for any ruby ever sold. It started as a chunk of aluminum oxide contaminated with chromium, survived the geology and every hand that touched it, and ended on an auction block in Geneva. That is not a typo, by the way. If you want exact coordinates for the Montana Sapphire Terraces and the Oregon BLM Sunstone Fields, I am going to show you next. Subscribe now. Every field guide I produce goes directly to this channel. Now back to the rocks. The feldspar family plays optical tricks that most collectors never learn to read. Moonstone, sunstone, and labradorite are all feldspars, each with a different internal structure producing a different light phenomenon. Moonstone's blue-white glow comes from alternating layers of orthoclase and albite, 60 to 150 nanometers thick, that scatter light internally. Labradorite flashes spectral color from phase boundaries between sodium-rich and calcium-rich layers. Oregon sunstone is copper-bearing labradorite, and the copper inclusions create pleochroism, meaning the stone shows different colors from different viewing angles. Pleochroism is field testable with a dichroscope, $35 to $45, an Iceland spar calcite prism in a metal tube. Hold it up to the sunstone in direct light, look through the eyepiece, and rotate the stone. If you see two distinct colors in the two windows, the pleochroism is real. One color means glass, or a singly refractive imitation. The Bureau of Land Management Public Collection Area near Plush in Lake County, Oregon, is free access, no permit, 25 pounds per day, plus one piece, hand tools only. Copper bicolor sunstone from this area moves at $20 to $200 per carat if you know what separates the gem grade material from the common feldspar around it. The spodumene family is where Afghanistan, Brazil, and a small fee dig mine in North Carolina all end up in the same sentence. Kunzite and hiddenite are two faces of the same lithium aluminum silicate, growing in the same lithium-rich pegmatites as Beryl. The crystal habit is the key field marker. Spodumene grows in long, grooved prisms, striated lengthwise. In a pegmatite face, the difference from quartz is visible at arm's length. Quartz is smooth and glassy. Spodumene is ribbed. Manganese colors, kunzite pink. Chromium colors, hiddenite green. The Emerald Hollow mine in Alexander County, North Carolina, charges $10 to $50 per day and puts you in the same pegmatite that has produced both. A dual-wave UV torch, $49 to $69 at 254 nanometer shortwave, makes kunzite glow an intense orange pink. Quartz and glass do not respond. That is your separation test in low light. And then I have to stop for a moment and tell you what the chemistry does not put on the certificate. Colombia, 1973. The government privatizes the emerald mines, and Victor Carranza, known as the Emerald Czar, consolidates control through methods that ended careers and lives. Rival tunnel networks were reportedly sealed with concrete. Thousands died in the turf wars between local clans and drug cartels across the next 2 decades. The Catholic Church brokered a peace deal in 1990, a fragile one. Martin Rojas, another emerald baron, was assassinated in 2013. The Green Wars never fully ended. Every Colombian emerald with a GIA certificate has a documented chemistry. Almost none of them have a documented provenance trail back to the original extraction. Provenance is not just auction catalog language. It is the part of the story no spectroscope reads. The Garnet family is where collectors make the most expensive assumptions, and I have made them myself. Walk into any gem show and you will see trays of deep red pyrope and almandine garnets for $2 a stone. That price is accurate for those varieties, but it has nothing to do with what uvarovite, demantoid, and olmite are worth. Uvarovite is a calcium chromium garnet, chrome green, found as tiny dodecahedral crystals coating chromite-rich ultramafic rock in the Ural Mountains. Demantoid is an andradite garnet with dispersion, fire, higher than diamond. Found in serpentinite near the Bobrovka River, first described in 1868. The horsetail inclusion, a fibrous chrysotile fiber inside the stone, is the fingerprint that confirms Russian origin. Russian demantoid, with visible horsetail inclusions, exceeds $10,000 per carat at auction. The inclusion that would drop the value of any other gem confirms this one's identity and source. Olmite, a new garnet species named in 2006 and found at a single mine in South Africa, demonstrates that the garnet group is still being mapped. We do not have the full picture yet. Field identification for garnet starts with the specific gravity float test. Same O-House scale and plastic cup. Garnet runs 3.5 to 4.3. Quartz is 2.65. Feldspar is 2.56. A stone that sinks hard while the quartz around it barely moves has made its case. The Mineralab hardness picks confirm it at 6.5 to 7.5. And garnet breaks rough, not in flat planes. No cleavage, just a gritty fracture. That texture in the hand is something you learn once and remember. But the fifth family is the one that still catches me off guard, and I have been doing this for a long time. Alexandrite is a chrysoberyl, beryllium aluminum oxide. Not a beryl, but closely related. It looks like an emerald in daylight, and a ruby under incandescent light. The chromium absorption band in Alexandrite sits exactly at the boundary between daylight and tungsten visual sensitivity. Daylight, the eye reads green. Incandescent light, the eye reads red. One stone, two colors, depending entirely on where you are standing. The first Alexandrite came out of the Ural Mountains in the 1830s, where a pegmatite intersected a chromium-bearing mica schist near the Malyshiva emerald mines. That intersection, beryllium from one source and chromium from another, is rare enough that fine Russian Alexandrite runs up to $155,000 per carat. The Smithsonian Institution holds a 65.7 carat. Cushion-cut Alexandrite, the largest known faceted Alexandrite in existence, valued at over $4 million. Anyone can walk up and stand 3 feet from it for free. I have done that, more than once. And it is still strange every time to see a green stone turn wine red as you shift your head under the room lighting. A $35 to $45 dichroiscope reveals Alexandrite's double color. You hold the prism up to the stone, rotate it, and both colors appear in the two windows simultaneously. Glass does not do that. Spinel does not do that. That 10-second test is the definitive field separation. So the picture comes full circle. The coarse gray granite in your creek bed is a pegmatite signal. The hexagonal crystal face in that granite is a Beryl family signal. The rounded pebble a hardness pick cannot scratch is corundum. The feldspar showing two colors through a dichroiscope is worth more than the one showing one. The long grooved crystal that looks like ribbed quartz is likely spodumene, and a UV torch tells you which variety in seconds. The heavy grain that sinks fast in a water cup is garnet, and it might be demantoid. The knowledge is the field test. Every person walking past that rock is funding your next find, whether they know it or not.